Hello everybody, this is Dr. Poti. I will be recording to you some of the dosage calculation problems. So some of this may be a review for you already because you have been doing dosage calculation, but just before you take your HESI exam and also your NCLEX, it is going to be a good review. So on this platform, I'll be using Word document. So just kindly bear with me as I try to play with the lines and with the numbers. So I'll try to do my best. And as always, if there is anything, you have my email and then you can reach out to me. So I'll be going over conversions, which is very much important, like centigrade to Fahrenheit and Fahrenheit to centigrade. I'll be looking at some of the PO, IM, IV medications and also IV drips, which is very important. We'll be also looking at some IV fluids. Okay, again, all of this is something that you know, but a quick review. So when you're looking at really converting centigrade to Fahrenheit or Fahrenheit to centigrade, I know that there are like couple of formulas that you can use. So if there is a particular formula that you're using and if it is working, please do not change anything. But for me, it is so much easy for me to remember one formula over two formulas. So what I do is, as I'm calculating the temperatures, I use the formula which says 5F is equal to 9C plus 160. So this is the formula that I use because I like to use one formula over two formulas because it is so much easier to remember. So, but then as I was saying, if there is something that is working for you, don't change anything. So for this formula, 5F is equal to 9C plus 160. We will be using our simple math. For example, like when we are looking at these numbers, we have like a variable, we have like Fahrenheit here and centigrade. And we see that Fahrenheit here is multiplying. So if it has to go to the other side, it is going to divide. And the same thing, like centigrade here is multiplying. So if it has to move to the left side, then it is going to divide. And also 160 here is positive. So if it goes to the other side, it is going to become negative. So we'll be using those simple math rules, probably which you might have learned in your elementary school, and we will solve this problem. So now we have 98.5 Fahrenheit, which you need to convert to centigrade, right? So I'm just going to plug in the numbers. So I say like 5 times 98.8. And I'm going to call it like this is equal to 9C plus 160. Now, once I multiply 5 times 98.5, I get 494. And I'm also going to take my 160 on the other side. So you can do it either way. You can just let's just do it this way. So 494 now is equal to 9C plus 160. And then you go back to the next step saying 494 minus 160 will be equal to 9C. So you go to the next step, which says 494 minus 160, and then you divide, right? So let me just get my line here. So I'm going to bring my number towards the other side, towards the left side, and this is equal to my centigrade. So this will equal to 334. 334 divided by 9. Yeah, this is the one I was asking you to be patient with me, because as I pull lines down, okay. This is equal to C, right? So which is nothing but that is equal to 37.1, which is nothing but our centigrade. So this is one way of doing it. So I like this formula better only because, as I was saying, for me, it is difficult to remember two formulas. So, and I don't want to get confused, especially when you're taking your exam. Probably you would have noticed, I mean, you might have studied the best that you could, but once you are there for the exam, I mean, you may tend to get nervous. So if you just remember one formula, you'll be able to like really solve any of these two problems. Let it be centigrade to Fahrenheit or Fahrenheit to centigrade. So along the same lines, we are also going to try the next problem. So again, we are going to apply the same formula. So in your NCLEX, you will be given a scratch paper or like a white board, like, or a dry erase board with a marker where you can write and erase. So please do make sure, I mean, if you have to like really use it, I mean, don't feel bad. I mean, because that's just the way that if you have to use uh, a whiteboard and a marker, you have to use it, right? So carry the formulas. Just don't think, oh yeah, I know it in my head, and then just don't start plugging in the numbers. It's okay to start writing the formulas, just that you're safe, right? So we have the formula here. So we are going to do the same thing again. So 5 times 101.4 is equal to 9c plus 160, right? So when you do all these steps, like, as you keep doing it step by step, so again, you're going to get 507 is equal to 9c plus 160. So you're going to do 507 minus 160. So this is again, you're bringing 160 on the other side, right? So, and then you can also, at the same time, you also can bring 9 on the other side. So in this way, you will just leave the variable c on your right side. So you have 507, and then your positive 160 is becoming negative 160 here. And you'll also try to bring in your 9 onto this side. So this will equal to C. So your answer will be 347 divided by 9. That is equal to 38.6 if you round it to the whole number, or nearest tenth. Sorry, if you round it to the nearest tenth. That is nothing but 38.6 centigrade. So again, if there is a way that you're using already, and if it is working the best for you, please don't change it. But if there is no particular way that you are at the minute using, and if you're getting like confused with whatever you're doing, then this is something that you can use. So our next problem is converting centigrade to Fahrenheit. So again, I'm going to take back our same formula down. So though you know your formula, I mean, or even myself, though I know my formula, I always like try to write down my formulas. So in this way, it is right there before me when I'm trying to solve my problem. So here you want to like find out F, right? So again, 5F is equal to, now I have my centigrade. So 9 times 37 plus 160. Right? So that is equal to 5 5F is equal to 493 So my F is equal to 493 divided by 5, right? So that is equal to 98.6. Okay, we'll just do another problem like this. So again, you would carry your formula or on your dry erase board or a scratch paper that is given to you. In your NCLEX, you're going to write down the formula. So these problems like seem to be like very simple when you look at them. So one thing that I like to say is in your exams, I mean, we have to be confident about what we do, but at the same time, don't be like very overconfident. Just like how you would give importance to arterial blood gases, I would say that even though it is like the temperature conversions or the weight conversions, make sure that you do give the same importance and read the entire problem, and also see like what is the rounding that they're talking about. Are they asking you to round to the nearest whole number or nearest tenth or nearest hundred, right? So make sure that you do that, and then all the time, like, make sure that you have your formulas before you. So we will do the same problem again. So it is the same thing. 5F is equal to 9C plus 160. Sorry, I had to put the numbers. So here again, I'm like, okay, let me just do it. 5F is equal to 9 times 37.5 plus 160. So 5F is equal to 337.5 plus 160. I'm just taking like the very, very simple route. I mean, I'm just breaking it down so much. You really don't have to. You can just plug in all the numbers at the same time and separate the variable. And then you can do it however you want it or whatever you're comfortable with. But I'm just using the most like, I'm like breaking it to the simple level. So this is, okay. So now we can just say like F is equal to, so in your temperature conversions, just remember that we always round it to the nearest tenth. So in your NCLEX, you will be getting, or you will be asked to round it. I mean, you'll have like clear instructions, but if you do not, just note that it will be, you will be given like clear instructions like round to the nearest whole number or round to the nearest 1/10 or 100. So just pay attention to that. So another problem that you have to know is definitely intake and output. I wouldn't be very much concerned about output because, you'll just be calculating the output, let it be like the urine or let it be like the vomiters, so whatever output it is. But then when we are really looking at intake itself, you might be having like, you might be having like ounce, or you may be using ml, or they may be just giving like a cup. So these are something that you have to like memorize. There is no other way of getting around it. So here now your problem says, okay, calculate the intake in ml, right, for the following food items. So everything here is given in ounce, and you know that 1 ounce is 30 ml, right? So again, so you will just like put the same numbers there. 3 ounces is nothing but 3 times 30 ml, right? So then that will be like 90 ml, and then you'll be, so it is the same thing. I mean, this problem is a very simple problem because this is only asking you about ounces, but also sometimes you may get problems like the patient is getting IV fluids 125 ml per hour. And then maybe they'll also give you, the patient had like a cup of broth and like so many ounces of juice or something like that. So you will have like multiples of units that you have to convert. And usually I do see that students, when you are given a problem saying a patient is getting 100 ml, or sorry uh, 0.9 ml per hour, uh, and what is the intake for 8 hours. Usually I see that students don't multiply that 100 times 8, because I mean, the patient is getting 100 ml per hour, and he has been getting it for 8 hours. That will be 800, right? So I don't see that happening. So and right away, like, as the student, like, looks at the question itself, they'll be like, oh my goodness, I don't know how I did this, how I missed this. So that is what I was speaking about, like, speaking about overconfidence. Sometimes when we see some things that we really know that we can do it, right? Sometimes there is every temptation to get overconfident. So you really, whenever you get any problem questions, however simple that is, make sure you use your scratch paper or you use your dry erase board, whatever is given to you, and then literally put in the numbers. So again, in this, like 60 times 30, 6 times 30, that is equal to 180 ml. So 9 ounces is again 9 times 30. That is 270. Then the next thing is 12 times 30. That is equal to 360. Now you add all of this, and now your total is going to be 900 ml. So make sure, suppose just say that you had a cup here, or just say that you had a IV fluid. So make sure you write each of that component, and then make sure you have your ml correct, because only then you'll be having your answer correct, right? So this is like, so these are the types of problems you may get in your NCLEX. So we have like another problem which we will be looking at. So here again, you have to calculate the intake. So now you have one and a half cup of broth, and you have 12 ounces of tea, and you have like 2 ounces of Jello and 16 ounces of Gatorade, right? So now this is what you'll be doing. So again, 1 cup is 240 ml. So these are the numbers that you have to memorize. I mean, there is no way of getting around these memorizations. So as we add in the numbers again, so 1.5 times 240, right? That is equal to 360 ml. And next is again 12 ounce, right? 12 ounce times 30 equal to 360. Then 2 ounces, right? 2 ounce times 30, that is equal to 60. So you have 16 ounce times 30, that is equal to 480. So as you total all this up, then you'll be getting like 1260 ml. So this is what you need to be careful about. If you have like cups and ounces, make sure that you calculate in the right way. So hopefully this is helping you a little bit. So we will look at like other types of problems that you can get in your exams. So you may be given, like when you're looking at like the PO medications or IV medications, you may be given medications like, in a picture format or an image format like this, or you may just be given in a statement. So you just have to be careful, because when you are given an image format, you'll be seeing numbers like 100 tablets, and you'll be seeing the dose here. So this is something that you have to be careful about, because this is like the number of tablets that are present in that container, right? So we have to know how to remove the fluff. So whenever you see any numbers like this that doesn't pertain to what you're looking for, then that is like the fluff. So really 100 tablets. It really doesn't matter if you had 100 tablets in the strip or in the bottle, or if you had 10 tablets. It really doesn't matter. All that matters to us is, okay, you have to give 0.5 milligrams of Lenoxin, and as of now you have 125 micrograms or 0.125 milligrams. Okay, you have like micrograms and also milligrams, which is like the conversion. So this is the dose that you have, and all you want to know is, how many tablets do you give. So use whichever, when you're like really doing dimensional analysis, uh, everybody would have like probably their own way of doing it. So as always, if you have a way that you're doing it, do not change anything. But if you're looking at something and if you really need a review, or if you need something that is more simple than what you know, then you can always like use the one that I'm using. So whenever I am doing dimensional analysis, I use like an acronym, AON. I mean, again, like, it's just mine. You can use anything that is like more comfortable for you. So I just say A. A is for available. So I'm going to be saying what is it that is available, right? And O is for order. What is it that has been ordered? And N is for need. What is it that I need? So that is how I go by. So for any problem, so this has really been helping me. So let it be like, problems like this, which is like, you have like tablets, and then, you just like do those calculations, or even like those critical care medications like dopamines and dobutamines and heparins and insulins. It really doesn't matter. So whatever I use, I always like use this AON. So what I mean by that is, when I'm looking at like this particular one, like available, what is it that I have available? So I can either take like milligrams or micrograms. It really doesn't matter, but I'm just going to take micrograms at this time, right? Because in this way, I'll be able to show you, how I set my problems up. So so what is it that is available for me? So I have 125 micrograms per tablet. That is what is available, right? So each tablet is like really 125 micrograms. And what is my order? My order says I have to give 0.25 milligrams, right? So I write it down, 2 point, sorry, 0.25 milligrams. And what is it that I need? How many tabs per dose? So this is how I just like, write down in the first place, like, what is it that I need? So this kind of like will really help me to simplify what is there. And also it will help me to remove the fluff, because sometimes your problem may say that, you are like, you are a nurse, and then, you have to give Lenoxin 0.25 milligrams, and you have a container of Lenoxin tablets and 100 tablets per container. So you'll have like all those numbers that are put in. So when I really look at, or when I really go by my acronym like AON, it is so much easier for me. All I need to do is like, okay, what is it that is available for me? What is my order, and what is that I need? So over here, it is like tabs per dose. Sometimes it could be like ml per dose. Sometimes it could be like micrograms per minute. Sometimes it could be, ml per hour. It really doesn't matter, right? So it could be anything. So that is why I use this acronym. And the next thing is, like, whenever we are looking at dimensional analysis itself, dimensional analysis is based on factor method. Factor is nothing but like the units method. So what I mean by that is, it is based upon the units of measurement. Let it be milligrams, micrograms, grams, kilograms, pounds, ml, milliliters or milliunits, or kilograms, pounds. So all this, it is based upon the units. So that is like, basically that is what it is. So whenever you're doing the dimensional analysis, so it is safe to go by the units. What I mean by that is, whenever you are laying your problem out, your units will lead you. So I'll just talk to you about what it really means. So now I will start my problem with what is it that I need. Now I need tablets per dose, right? So now I'm going to say I need tablets per dose. So over here, kindly bear with my lines here as I'm putting the lines, because it really helps you if I really draw this line. So, it just helps you with your understanding. So I'm going to go by like tabs per dose. So when I say unit method, dimensional analysis is unit method, what I mean by that is uh, once you lay your problem, let it be like 5 units, or let it be like a linear problem, let it be 10, 15, whatever it is, it really doesn't matter. But your units have to cancel in zigzag manner. That means like numerator and denominator. The units have to cancel out. So once you cancel out all the units, whatever the unit that is remaining should be what is it that you're needing. For example, here you need tabs per dose, right? So as you lay your problem, and then as you cancel, like let it be like kilograms, kilograms, micrograms. So as you keep canceling that out, towards the end, if you do not have tabs per dose remaining, that means don't even worry to calculate the numbers, because your problem is wrong. So I like dimensional analysis because it's all as if like it is like a security measure for me, and also it saves my time, because like okay, I lay my problem, I cancel my units, and if I'm not getting what I need towards the end, like for taps per dose or milliliters per hour or mics per minute, whatever it is, if I'm not getting what I'm looking for, that means like I can safely erase everything and then start over my problem. It's really like a sort of like a security shield. So now I see that, okay, now I need like tabs per dose, right? That means like after I cancel out all my numbers, I need to have tabs in the numerator, dose in the denominator. So now I'm going to be looking at, okay, so what in the problem has something with the tabs, right? So it is nothing but here it says one tab is 125 micrograms, right? So that is what I'm going to start my problem with. So one tab. So one tab is 125 micrograms. Oh, sorry. So one tab is 125 micrograms, right? This is where we got it from our image. And sometimes it also could be like in your problem. So I'm going to write that 125 here, 125 micrograms. And remember we were saying like, basically this is a unit method. And if you have in your denominator, if you have micrograms, then in your numerator, you should have micrograms, right? Because then they can cancel out. So I'm going to look in the problem and see, like, do I have anything other than other than 125 as micrograms? I really don't have anything pertaining to micrograms, but something that I see is my milligrams, right? Because 0.25 milligrams. So now this is microgram and this is milligram. So now I'm going to use it as a conversion. Because I have micrograms in the denominator, I will still need to have micrograms in the numerator. But because I have milligrams, I can use this as a conversion factor. So now I'm going to say 1000 micrograms is equal to 1 milligram. Okay, give me 1 second. Okay, so now I have like micrograms here that I can cancel out. Now I have milligrams here, right? Now remember I need like tabs per dose, right? But not milligrams. So now I'm going to like I'm going to carry this milligrams over here. So now I'm going to be seeing in the problem to see, okay, what is that has milligrams? It is 0.25, right? So that is the number that I'm going to carry there. And what is that 0.25 connected with? That 0.25 is connected with one tab, right? That is what it says, right? Sorry, dose. that is the dose, right? I'm trying to like play with my numbers here or my lines here, and I'm getting mixed up with my numbers. Okay, so as you look at this, so what is the 0.25? So this is the order, right? That means per dose, that is what it is. That is what the physician wants you to give. So now you're going to say, okay, so I need to give 0.25 milligrams per dose. So now you pretty much used up all your numbers, right? So let's just review one more time. So your order is Lenoxin 0.25 milligrams. How many tablets per dose do you give? And again, as I was saying, you go by that acronym. If there is something that you're using, continue to do the same. Don't change anything. So I use like available, I have 125 micrograms. My order is 0.25 milligrams. That means it is nothing but per every dose, I have to give 0.25 milligrams. And what I need now to calculate from this problem is I need to find out how many taps per dose. So because I need taps per dose, that is how I'm going to start my problem with. So I'm going to start my problem with taps per dose here. So once I say, I need to get tabs per dose. So my first step has to start with the tab. So most of the time. So now one tab is 125 micrograms. Because I have micrograms in the denominator, I start with micrograms in the numerator. And basically, I'm going to use it as a conversion factor, right? And then towards the end, I'll be able to cancel it out. So I'm using 1000 micrograms is 1 milligram. And because I have milligrams in the denominator, I start with milligrams in my numerator. And when I look at my problem, what is it that is connected with the milligrams? It is 0.25 milligrams. And what is it connected with? Per dose, right? So this is how it is. So now I canceled my units. Now when I really look at the units that are remaining, I have tabs, right? One tab that is remaining, and I have dose that is remaining. So now I know that, even the way that I laid my problem is correct. Just say that if I did not have like tabs per dose, and or if I had remaining like milligrams or micrograms, then my problem was wrong. So now I know that, okay, that's great that I set my problem correctly. Now I multiply everything on the numerator, and then I multiply everything on the denominator. And then that will be like my, and then when I divide, that is going to be my answer. So as you multiply, you'll be getting 250 divided by 125. That is equal to 2. And what is the 2? 2 tabs per dose. So this is a very simple problem. Probably you would be able to do it like in 1 minute or even less than 1 minute. But I just took time to explain this a little bit, because if you just nail this concept down as to, like how to like, really find out like, what is available, what is the order, and what is it that you need. And if you just like find out how you lay your problem, and also how you use like the conversion factor, if you know this, then you'll be able to solve any problem along these lines. So we will look at like another problem. So here the order is 750 micrograms, and how many tablets per dose do we give? So when we look at our tablets itself, our available is 0.25 milligrams, right? And we need to give 750 micrograms. So we are going to, again, I'm going to use the same acronym that I used. Give me 1 second. So I'm going to use the same acronym that I used, because that is the way that I keep my things organized, and I'll be able to remove the fluff if there is any fluff. So over here now I'm going to say, what is it that is available? Okay. And then what is the order? Right? And what is it that I need? Right? So as I look at it, what is it that I have available? I have my each tablet is 0.25 milligrams. That is what is available for me. And when I look at my order, I need to give 750 micrograms, right? So for every dose, I need to give 750 micrograms. So what is it that I need? The problem is asking me how many tablets do I administer, right? So what I need is tabs per dose. So because I need tabs per dose, I'm going to start off my problem with tabs per dose. Okay, I'm going to start off tabs per dose. So again, I'm going to really look at okay, what is it that's really talks about, anything about tab. So in my problem, I know that one tab is equal to, one tab is equal to 0.25 milligrams, right? So I have one tab and that is equal to 0.25 milligrams. Now, because I have milligrams here, I want to have milligrams, right, in the numerator also. So I go by milligrams, but really I don't have anything with milligrams, but I have micrograms, right? So now I'm going to use the conversion. So I'm going to say 1 milligram is equal to 1000 micrograms. And because I have micrograms in the denominator, I want to have micrograms in the numerator. And what is the number that is associated with micrograms? It is 750, right? And what is that 750 micrograms? It is nothing but per dose, right? So now I used up all my numbers. So it is the same thing again. I cancel my units. I have milligrams in the denominator, milligrams in the numerator, micrograms in the denominator, micrograms in the numerator. And what is remaining for me is tabs, dose, and that is what I want, right? I want like tabs per dose. So now I know that even the way that I laid my problem is correct, right? So now it's going to be 750. So you're multiplying everything in the numerator. So once you multiply that, then it's going to be 750 because 1 times 1 times 750, right? And then here it is going to be 0.25 times 1000, that is equal to 250. So now you will get 3 tabs per dose. So now you know that, okay, so because now you know that this problem is correct because you were able to cancel out all the units, and the remaining units that you had really is what you were looking for. So this is like a way that you can use, this is, one of the way, by using acronym of AON, you'll be able to solve these types of problems. So over here, it is pretty much like PO medications, but then, probably in some other problems, you may get the same concept, but it could be like ML, like where, it will be the same numbers, but rather than MG and PO, you may be given like ML. So if you master this concept, then you should be able to do any of the other types of problems. So with this, I'm going to stop this particular recording and I'm going to start recording the next, sub Qs and also IVs in my next recording. As always, if you have any questions, you can always reach out to me.